The dimensional envelope of the heavy bomber established an immediate physical boundary for institutional preservation efforts. Planners evaluating the Boeing B-29 Superfortress faced a severe geometric constraint directly tied to the primary architecture of the aircraft. The structure featured a rigid, continuous wingspan of roughly 141 feet across the lateral axis. This massive horizontal profile was further complicated by a central fuselage length just over 99 feet from the forward crew compartment to the tail turret. These fixed geometric realities exceeded the spatial capacity of all existing aviation museum infrastructure available to the custodian institution. The primary museum facilities located on the National Mall were constructed to house much smaller historical artifacts, primarily single-engine fighter aircraft and early biplane configurations. The heavy bomber simply could not fit through the available hangar doors, nor could it be positioned within the existing climate-controlled exhibition halls. The rigid design of the wing box prevented any temporary folding or geometric reduction that might have allowed indoor storage. This absolute physical limit forced the institutional planners into a difficult operational trade-off. If the historical airframe could not be placed inside a protective building, the only remaining option involved placing it outside. The institution recognized the historical value of the artifact but possessed no immediate architectural solution to the spatial problem. The operational requirement demanded securing the aircraft, which meant finding a concrete footprint large enough to bear the static load of the bomber while providing basic perimeter isolation. In December 1953, after the Smithsonian still lacked a building large enough to house it intact, the aircraft entered outdoor storage at Andrews Air Force Base in Maryland, securing the necessary footprint while leaving the polished airframe exposed to weather. The public museum record confirms the outdoor storage condition, but it does not document a detailed preparation sequence for draining fluids, sealing hatches, or locking control surfaces. The aircraft's wartime exterior was a polished overall aluminum finish with painted insignia, group markings, serial markings, and the Enola Gay name on the nose, not a fully paint-protected exterior skin. This exposed, polished aluminum construction amplified the risks associated with the tarmac storage location. The planners had secured the physical asset, but they had fundamentally lost control of the surrounding storage environment. The aircraft was parked exactly as it had operated, resting on its original landing gear in an open field without any environmental control systems. The structural volume that enabled the aircraft to perform its high-altitude missions now became its primary vulnerability during static storage. Institutional managers understood that the exposure would deepen over time. The bomber entered a prolonged holding pattern, waiting for future museum expansions that would take decades to materialize. This mandatory outdoor staging solved the immediate spatial crisis, but initiated a slow, continuous test of the original manufacturing materials against natural forces. The operational trade-off maintained institutional custody but placed the primary physical evidence in direct conflict with the environment. What structural consequence followed this mandatory outdoor exposure? The atmospheric degradation of the unprotected heavy bomber commenced immediately upon its arrival at the outdoor tarmac. The seasonal weather of the region exposed the airframe to continuous freeze and thaw cycles, causing the massive aluminum panels to expand and contract. Moisture penetrated unsealed gaps and collected in lower fuselage sections, bulkheads, seams, and fang surfaces. Galvanic corrosion requires dissimilar metals in electrical contact and an electrolyte to complete the chemical cell. In this large aircraft structure, aluminum skin, metal-to-metal joints, fasteners, doublers, and internal steel components could create localized corrosion risks when rain, snow, and humidity kept those areas wet. The original 1945 polished aluminum skin and wartime markings remained central to the aircraft's authenticity, and without a full paint layer, the exposed surface could dull, pit, and corrode under repeated weather exposure. The environmental risk extended beyond natural forces. While the aircraft sat outdoors, some equipment disappeared or deteriorated enough that later restorers had to replace documented missing items, including radio gear and antenna components, and search for period Boeing logo caps for the cockpit control wheels. The surviving public restoration record identifies some missing categories, but it does not support an absolute claim that a complete stolen inventory is known or unknowable. The safer conclusion is narrower. Some original components were no longer present, and replacement or period-correct parts had to be documented during restoration. This material loss created a strict proof limit. The cockpit configuration cannot be entirely verified or perfectly restored because parts of the original baseline evidence were no longer present. Removing flight instruments without proper documentation eliminates the operational context of the control deck, severing the physical link to the 1945 configuration. Together, uncontrolled climate and uncontrolled access compromised both the aircraft's structure and its historical record. The degradation accelerated continuously over the 7-year storage window. The lack of active maintenance meant that the oxidation process proceeded without any physical intervention or chemical inhibition. Internal steel components rusted, threatening the structural joints that held the massive wing sections to the central fuselage. The greenhouse effect generated by the sunlight striking the plexiglass cockpit enclosures heated the interior air, accelerating condensation and trapped moisture cycles within the sealed compartments. The institutional planners monitored the ongoing deterioration and realized that passive outdoor storage was actively destroying the historic artifact. The trade-off made to solve the dimensional constraint was now causing irreversible physical damage. The unpainted metal could not survive the regional humidity, and the historical record could not survive the unsecured perimeter. The custodial institution faced a total failure of the preservation environment. The planners determined that continued outdoor storage threatened both deterioration and further loss of historic material, making drastic intervention unavoidable. How could a heavily deteriorating 99-foot airframe be rescued before destruction became irreversible? In 1960, the custodial institution executed a severe operational decision to halt the ongoing environmental destruction of the airframe. The planners recognized that moving the intact aircraft indoors remained geometrically impossible due to the massive 141-foot wingspan. The only viable procedure to save the historic metal required deliberately dismantling the unified structure. This emergency intervention utilized the concept of protective fragmentation. Technicians systematically broke down the heavy bomber into its primary structural subassemblies. The physical act of dismantling the aircraft required extreme care, but the public museum record confirms the result rather than each shop floor step. In 1960, the airplane was disassembled into major components, and those sections were moved to the Smithsonian Storage Facility in Suitland, Maryland. This procedure converted the unified aircraft into sections that could be moved under cover. Breaking a historically significant artifact into pieces inherently violates standard museum conservation principles, which prioritize maintaining structural coherence. However, the extreme atmospheric threat left the technical team with no alternative options. The disassembly process successfully neutralized the initial dimensional envelope constraint. Once fragmented, the individual sections possessed physical dimensions small enough to fit through standard industrial hangar doors. Every crane lift required custom sling placements to avoid crushing the fragile, unpainted exterior panels. The recovery team loaded the separated components onto transport vehicles and moved them to the Paul E. Garber Preservation, Restoration, and Storage Facility. Inside dry covered structures, the vulnerable aluminum was isolated from the regional weather cycles, halting active atmospheric degradation. However, executing protective fragmentation introduced a massive new operational challenge for the custodial institution. The team now had to manage thousands of separated structural parts, steel fasteners, control cables, and internal subassemblies. The operational focus shifted to preserving identity and context across the separated components, with staff documenting major assemblies and maintaining custody control so the airplane could later be restored as close as possible to its wartime condition. The storage facility provided a stable and secure environment, allowing the pieces of the heavy bomber to rest safely on specialized storage racks and custom support cradles. The 1960 intervention stopped active environmental destruction and preserved the material record, but it left the aircraft structurally scattered for decades while planners developed a funded restoration strategy. With the structure safely isolated in indoor storage, the next major challenge involved processing the damaged material. How could decades of established oxidation be reversed without destroying the original metal surfaces? Formal museum restoration work on the fragmented aircraft components commenced in December 1984. The primary technical objective was to remove decades of atmospheric corrosion without following the standard commercial repair practice of replacing damaged skin with newly manufactured aluminum sheets. Museum conservation rules prohibited that shortcut because the artifact's historical value resided in original 1940s unpainted metal. Replacing it would have created a replica rather than preserved the bomber. Museum staff, volunteers, and interns therefore cleaned and polished the surviving aluminum slowly, stabilizing the aircraft as close as possible to its wartime condition. The operational procedure demanded patience and forensic discipline, with specialists working inch by inch across the separated fuselage, wing sections, and tail assembly to expose clean, stable metal while preserving the polished aluminum finish and documented markings. The meticulous removal of the oxide layer generated fine metallic dust, requiring continuous extraction and environmental control within the workspace. The total restoration effort consumed 300,000 staff hours over nearly 2 decades of continuous labor. This staggering investment of time reflects the massive physical cost of maintaining material discipline. The technical team refused to compromise historical evidence for speed, stabilizing the original metal, retaining the authentic 1945 configuration, and reversing the severe surface damage from outdoor tarmac storage. As the treatment progressed, the separated components regained a stable museum display condition and a coherent wartime appearance. The technicians rigorously logged the completion of each subassembly, maintaining the component custody tracking established during the initial disassembly. The completed treatment validated polishing over replacement and left the separated components ready for transport. How could the massive polished sections be transported to a final unified location? The successful completion of the micro-abrasion stabilization left the historic heavy bomber in pristine material condition, yet the aircraft remained completely disassembled. The Paul E. Garber Restoration Facility could not support full structural reassembly, so the custodian institution built the Stephen F. Udvar-Hazy Center in Chantilly, Virginia, with the climate-controlled volume required for the complete aircraft. The operation shifted to moving stabilized, fragile subassemblies from Suitland, Maryland to Chantilly, Virginia, over public highway infrastructure, where distance and road transport introduced new handling risks. The separated wing sections and the long fuselage segments required specialized heavy transport vehicles designed for extreme wide loads. Over a period of weeks, 12 heavy truckloads carried the verified component inventory from Suitland, Maryland, to the new Udvar-Hazy Center. The operation demanded disciplined sequencing, custody control, and protection of restored surfaces. The verified record supports controlled handling at the scale, sequence, and destination of the move, but not a specific list of route control equipment, suspension systems, or driver procedures. The logistics team executed the move in a highly sequenced operational flow, delivering the sections one by one to the vast concrete floor of the new hangar facility. Upon arrival at the Chantilly, Virginia facility, the teams visually inspected every polished panel and structural joint, verifying that transit had caused no new mechanical damage or surface scratching. The unloading procedure mirrored the precision of the 1960 disassembly, utilizing slow crane hoists to lift the components from the transport trailers onto the staging supports. The fragmented parts arrived safely within the new, permanent climate-controlled envelope. The artifact was finally positioned within an architectural space large enough to support its true scale. The massive polished sections rested securely on the hangar floor, awaiting the final engineering challenge. How would the separated structure handle the immense physical stresses of a final mating? The final structural mating of the heavy bomber commenced inside the new mega hangar facility in 2003. After 43 years of separation, reassembly required exact geometric alignment of the primary fuselage sections, the wing box, and the tail assembly. Using overhead cranes and precision hydraulic hoists, operators maneuvered the polished structures into their original 1945 positions for final mating. The structural mating required the technicians to carefully reinstall thousands of steel fasteners, securing the massive wing roots to the central fuselage carry-through structure. The operators used calibrated torque wrenches to ensure that the physical connections met the required tension specifications without warping the adjacent polished aluminum panels. Reconnecting the internal control cables and mechanical linkages completed the stabilization of the control surfaces. The technical team conducted rigorous geometric surveys throughout the reassembly process, ensuring that the lateral and longitudinal axes of the bomber remained perfectly aligned. As the components locked together, the primary engineering constraint shifted from atmospheric degradation back to sheer physical mass and static load distribution. The fully assembled artifact did not represent an empty display weight of 137,500 pounds. The museum object record gives the artifact weight at roughly 71,826 pounds, while 137,500 pounds is a published gross weight specification. The original landing gear still form part of the aircraft's restored appearance, but the documented display decision should not be framed as a certain tire, seal, or undercarriage failure. The museum's published explanation states that the aircraft would be raised off the floor on stands to accommodate other aircraft under its large wings. The museum described the Enola Gay as displayed off the floor on 8-foot-high engineered stands, a configuration that supported the exhibition plan and made use of the vertical volume inside the new hangar. The aircraft still appears complete to the observer, but the script should describe the support system as display stands rather than undocumented concealed jacks. This elevated configuration also serves a secondary exhibition purpose, allowing clear viewing of the undercarriage mechanisms and the fully open bomb bay doors without risking a structural collapse. The meticulous reassembly restored the coherent physical identity of aircraft serial number 4486292. Its 141-foot wingspan now sits inside a permanent, climate-controlled envelope built for its scale, while engineered display stands support the exhibition plan and allow the bomber to be shown complete. The original polished aluminum skin and documented wartime markings remain preserved in a stable museum environment. The heavy bomber survives intact inside the hangar, no longer exposed to the open weather that once threatened its future.